Let's welcome Ryan and appreciate having him back.
Thank you. All right, I've actually got two presentations today. Crazy, this one's actually, the first one's really short, it's more of an announcement. But I was trying to get SecKC signed up for something and realized that Microsoft might have an issue. So, hacking nonprofits for profit. Step one, it's a pretty short process, is you look up nonprofits. There's websites that give you their EINs and addresses. Step two is go to nonprofit.microsoft.com/register, sign up using that info, and I used my own Gmail account address. You create a user ID, they give you a on Microsoft domain, then you just wait. You check your email, and like 4 hours later, I was approved. SecKC was an approved nonprofit, eligible to receive discounts from Microsoft. And then my favorite part was when you log in, it gives you $5,000 in Azure credits to use per year as a nonprofit. Which I thought was pretty neat considering they did like zero checking of any kind. I didn't use any SecKC emails or anything, so I think you could just kind of loop through a bunch of nonprofits and sign up for a lot of Azure credit if you really wanted to. But we'll have to figure out what to do with all that. I was thinking maybe the CTF people could maybe host some stuff and we could have it up all the time. Or they do have some hardware discounts also if you want to buy Microsoft Surface tablets.
Can we host the tip spot on there?
Might be able to get him back up.
Finally!
The software discounts I thought we'd be able to use, but it's for like on-prem devices only or something for nonprofits, so I don't really want to get into that area. But yeah, so we've got some Azure credit to use and we'll have to figure out what to do with that. So now, the global admin talk. One of my favorite things to do is find XSS. I talk about it quite a bit. I know lately I've been talking about a lot of Active Directory, but XSS is kind of where I started in security really. Well, maybe like hacking Wi-Fi and your neighbors and stuff, but XSS is pretty bad. A lot of people just think all you do is pop alert boxes and that's all you really get out of it. But I'm gonna hopefully persuade you that it's a little bit worse than people think. This whole kind of idea came from a story I read. This was up on like Medium a while back. I don't know if people read this or not, but this guy wrote this kind of post about I'm harvesting your credit card numbers and passwords from all kinds of different sites, and you don't really know about it. The whole idea was that you create a silly, weird piece of code, maybe that'd be somewhat useful to some projects. In like this case, I've got a little console application that just changes the output so that your console is now colorized. What you can do is then use different minifying and obfuscating techniques, and he was hiding a bunch of JavaScript that would basically, anytime it was on a page that had credit card numbers or passwords in it, it would scrape those and send it off. And it was really convincing because they talked about a lot of ways you can sneak PRs in and people won't maybe check every little reference you make in some open source projects. And if you have something that looks quirky and kind of like a nice feature, like colorizing the console, you can then push that out to as many open source projects as you can and just hope you get accepted by one or two. And then instantly you're referenced on tons of websites and all of a sudden you're stealing data off tons of websites. And they made it really sneaky. They made it so that it maybe only does checks every fifth time it sees a site that the user visits that has a credit card or password on it. They obfuscate everything. They change the different servers that they collect these on. They don't run if the domain that it's running on is like dev or UA or test. And so they try to hide this so that even if people are using this on their own personal sites, they maybe don't notice that it's got this malicious data in it. So the whole idea was kind of just to find a way to make something really weird, sneak some malware into it, and then submit it across a bunch of different sites. And I think it's maybe a little more possible than he really said. So today I'm going to be talking about some features of HTML5, some stuff that got introduced really back in about 2014, 2015. We'll look at WebRTC and some prior works, and then this little demo-ish thing I have that I don't have a vulnerable server up anymore because I had a crash. Then we'll look at some other crazy HTML5 features that you can do all through basically cross-site scripting.
Hosted on Azure.
There we go. So, WebRTC. WebRTC is a HTML5 spec to add real-time communications or real-time media communications to websites. This was way back from 2011 when they announced it. It's real popular with anytime you do video conferencing, it's probably using WebRTC. That was kind of like its major thing up at first. This is all done in JavaScript, so you don't have to add any plugins or you don't have to accept anything. And it provides the browser's access to devices, including like your camera, the microphone, screen, and sockets. So if you go to the HTML5 Rocks, my first WebRTC, a few things that WebRTC applications can do is get streaming audio, video, and other data. They can get network information such as the IP addresses and ports of the host they're running on, and they can exchange this data with other clients known as peers. They do peer-to-peer talking on networks, and this can even go through NATed networks and firewalls. So those sound a little interesting, considering this is all just being hosted on web pages. WebRTC, kind of how the whole thing works, to be able to send that data between different clients or browsers is ideally what it's supposed to be working on, but because you can access raw sockets, you can actually send it to any host. You can read the text, the mouse movements, get images, files, etc. You can send those over the line. So that's how you're doing screen sharing, things like that. This all resides inside the browser. You don't really have to click OK. These things are just available to run. WebRTC has plenty of demos. You can go visit their sites and look at how it works. I won't get too deep into the actual code part, really. There's a picture of how it works on the bottom, and if that looks kind of familiar, maybe you've seen that in some kind of security write-up, that's because I thought it looked a lot like how botnets look. There's a signaling server, and then they shoot out commands to these other little hosts that are running. So the real-time communication without plugins is kind of their whole thing. It's the RTC peer connection is the API responsible for managing those connections. There's two specific traits. It has peer-to-peer communication between the browsers or hosts. And this also can operate over UDP, which is a lot more quiet on networks too. It needs a way to send those messages. That part is not described or really documented in WebRTC. They kind of leave it up to the developers to pick however they want to make the web pages make requests and talk to the other hosts. Depending on which protocol stack you're going with, if you're on TCP, and developers out there will know this kind of stuff. You have XHR, SSE, WebSockets you can open up. And on the UDP side, there's ICE, Stun, Turn. These things work around NATed firewalls. I don't want to go too deep there. The ICE is the Interactive Connectivity Establishment. It's the framework used to establish peer-to-peer connections between clients on a network. The problem they had originally with this and why they had developed this was because if I know your IP address, that's probably your public IP address and not your actual host computer's IP address, and so we need to get through those firewalls and actually talk to your host. So they figured out a way how to make it basically bypass all that and natting and everything, and try some different things to get different routes, and basically chooses the best route to another host. It's important to us really because it gets us internal network addresses so that we can actually find these hosts, and provides a way to communicate to these internal hosts on any port we want to talk to. It was, of course, designed with some safety in mind, that they thought, okay, well, browsers are sandboxed, so we can't really escape out of the browser. The scripts can't interact with the underlying OS. Okay, that's fine, we can only send things out. There's same origin policy in cores, which I'll talk about a little bit later. These are some of the preventions / things that lessen the preventions on which apps can talk to other apps. If you've done pen testing and you see clickjacking and things like that, it's a lot of times just missing headers on servers, but it's who they'll accept connections from, who they won't. We can access the media and local resources, camera, microphone, but the users are prompted for any of those actual device access things. And then encryption is mandatory, so all this stuff always talks encrypted, so it's a lot harder to look at. And that's kind of the neat part too, is that this will be a lot harder to find on your network when it's communicating. So to look back at what some people have already worked on, there's a guy, Matt Bryant, he developed a tool called Sonar.js. This is like a really smart Google software engineer, security guy. His idea was basically that we can identify other live hosts on these networks, and we can actually fingerprint them based on the resources that they have. Because now that we have the ability to probe internal IPs on their network, and I'll show a little bit of that later, but the WebRTC has calls that basically let me get the local host IP, and then using just CIDR notation, we can kind of scan the /24 based on that host's IP. So that we can scan their internal network. And then by hooking different requests, and by hooking I mean like, if you try to request something with like an onload event without having to know too much JavaScript, it will either error out or not, and if you set a timeout when you try to load something, you can kind of identify whether that resource is actually there or not. So his idea was, okay, well, if I can do that, then maybe I can identify like certain routers. And he wanted to identify routers based on their unique set of, like when you go to the login page of any router, it's going to load a couple different images. And those are pretty unique to each router. And so you can correctly identify what router people are running on their home network by making requests to known router defaults like 10, 10, 10, 1 or 192.168.1.721, whatever. And so assuming, this is the kind of assuming part of his, is that that user is authenticated to their router, so they've got a session up, then he can make a request on behalf of that user, and this is kind of a cross CSRF attack, behalf of that user, where anyone that hits his web page, if his JavaScript can correctly identify a certain type of router, he knows the request he needs to make to change the DNS settings of that router. And this is on these people's internal network. So now he can point the DNS to his own and basically man in the middle anyone that visits his website. And that's kind of where we're going to build on the rest of these exploits. So how this works is he's opening a WebSocket. I'm sure you can't read that at all, but I may be zoomed in so you can read a little bit, but you're going to check an IP, you open a socket, open up these WebSockets. To an IP, you generate a random ID. You're assuming you're going to scan the whole /24. You hook all those other different functions, the on-air, on-close, on-open, and you kind of just try to identify whether you were able to get that resource or not. You save all those, compare them to a database of fingerprints that have been developed, basically by going and visiting the home pages of a bunch of these different routers. And then this is the timeout function that you can see. If a host is basically alive or dead, and that's how you can kind of, that was like the first steps in being able to map internal networks through basically a cross-site scripting attack. So this is more of the router. So like an ASUS router has those certain zip files and style CSS, and you know they're always going to be at that 192.168.1.1 address. So I just know I can scan that, check for all those images. If they're there, I can identify that is for sure an ASUS router, and then make that post request that's going to change the DNS settings. So to identify those other resources, this is probably deeper into the code too, but they build a bunch of attributes. You hook those attributes, and whether they load or not, their images, IDs, added a bunch of different stuff, so you can save all this in a database. It doesn't really matter. The fingerprint database is what it's going to compare to. This is another file that's just JavaScript that's also hosted on that page. Basically, you pick a router, you tell it what resources are going to be there and where, and so you can add to this thing. This is open source, so people have been adding, and now there's like tons of routers that have been mapped and identified to this. And then we added callback functions, so that if you do identify that router, then you would put in that exploit code. Now, to generate that exploit code is actually pretty easy thanks to Burp Suite. Burp Suite provides us, so this is a post request captured in Burp Suite that is actually making a DNS change. If you capture that in the proxy, there's a function of like the generate cserv POC you maybe have seen if you've used that much at all. That will basically generate JavaScript for a page that it wants you to run on your own that will demonstrate kind of the cserv attack. All you can do is then just generate that cserv POC, copy and paste the code that actually makes the request. You can get rid of the rest of the HTML. And you paste that into that same fingerprint. This is just a view of that ASUS router. The images are up top, and then that actual XHR request that makes those changes is down below. So once it correctly identifies that router, it'll fire off that exploit. So the actual exploit page is pretty simple. You have to import the Sonar.js script and the fingerprint database script, and then you just start, and then it just runs. And it's as long as the people are on the page, it'll be scanning their /24, trying to identify all these different resources. This is kind of the example of all the default routers that kind of have known IPs. If you've ever set up a wireless network, you know that you're always going to have one of these types of network addresses, the 192.168.1.1 or 172.16.0.1. That's been another thing people have kind of contributed to and gathered up is they loaded all these routers up, figured out what are all the pretty common defaults people use, and so we can kind of create a list to scan those and then try to fire this exploit off. FlexLM is someone that made a pull request. I don't think Sonar ever accepted it, but that request added the ability to actually just pick any range of addresses. So now I can actually just load up and tell Sonar to start on 10.0.0.1, regardless of what the local host is. So we can actually pick any network ranges. And the only thing that really hinders this is just the time that they spend on that web page. That's that guy. So then Beef, most people probably heard of, that came along. It's been out for a long time, but they started to add some of these features. Beef mostly focuses on the client themselves for the exploits. You set up a browser hook, which is basically like a JavaScript file you can embed with like a stored cross-site scripting goal, or reflected if you get someone to click. You embed your hook, and then they added the network scanning abilities that Sonar had. They basically imported all that, so now it's in Beef, and they give you nice little graphical references of what the networks look like. They added a lot more fingerprints for different web servers, because the same thing worked, so that if you have a Tomcat manager, I can request every one of those resources to the HTML/manager, and then check for images on there that map to Tomcat, and pretty reliably tell you what type of Tomcat server they're running on those hosts. And all these basically you can just post back to a listening server just with a GET request, all the info you need, and then that server that's listening in all of its logs will have all this information that you can extract. So then Beef started taking a look at more of the WebRTC features. They kind of use that get internal IP address. They imported that landman figure so you can actually just pick IPs and start scanning them, all with the intention of ideally like changing these routers' DNS entries and exploiting them. And then they added some CORS and cross-origin scanning tools that can actually tell you whether CORS is enabled, which are some of the protections. Basically, it's going to stop any other website from like getting resources from your website. The problem with that is that it doesn't really prevent you from making that request. So if I don't care what the responses are, it doesn't affect it too much. And that's where I move into the one-shot payloads that have came out. In the last, I'm just saying the last few years, it's really been for a long time that we've seen one-shot payloads that do malicious things. But through basically like a GET or POST request, we've got a lot of different exploits that we can pull off that basically cause remote code execution. There was Drupal getin, that's kind of like a one-shot curl request that will then result with command execution. Apache struts was pretty recent and a big one that was in the news. There was, this is an Apache Tomcat where you can just put up a WAR file and post it. Shell shock, there's one in the user agent headers. That's a header you can set with XHR requests. CyberArk had an RCE just recently in the password vault that basically would let you unlock the password vault and pull the details out of it. IIS-6 prop find, that's a one-shot vuln that came out on against a really old shot. Yeah, I did say one shot, I guess. I just got the one.
So fix that.
Glad that was just one shot. Yeah, so IIS-6 prop find, it's a single shot, one payload, right? And this is kind of all getting back to, and one of my favorites, Java deserialization vulns. These are usually done with a single request to an endpoint, like the invoker servlet. There's one in the view states cookies. There's lots of Java deserialization vulns, but there's plenty of vulnerabilities out there that if you know that the host is there and vulnerable, you can fire off exploits that then will get reverse shells back. And what we kind of am getting at here is that you can put all this together so that you can reliably, through cross-site scripting, fingerprint hosts that are vulnerable to one-shot payloads and then fire off exploits that get reverse shells on internal network hosts. So that even if most networks are getting better about having the perimeter be pretty secure, but if you've ever done any kind of pen test work, you know that the internal networks usually have a lot of out-of-date things and a lot of vulnerable services. Well, now we're talking about any of your users browsing the web, and then as long as, I don't know how many of you keep tabs up, but I usually have like 50 tabs up running all the time. Well, as long as that thing's up and not paused, it can be constantly scanning your network and trying to identify and fingerprint these hosts. So could we use these HTML5 features to scan the internal network, identify hosts, and gain code execution? I think we could. I've been poorly trying to design some tool to mostly do all this. I mostly base it off Sonar's work. I've been looking at adding beefs, coors, and cross-origin requests to kind of check that way, instead I'm not firing things off that I know aren't going to work. But basically, it's going to take in a host or network, and then you're going to pick your exploits you want it to load up. You generate that. It's going to give you JavaScript, and another feature I haven't quite got to, but we'll talk about that in a second, actually. Let me bring it up, actually. Here. Which I don't have the vulnerable. I had an IIS-6 server running that was going to be vulnerable to this, but it broke. So this is this guy running locally right now. So you can basically pick from a bunch of these single shot vulnerabilities that I've been working on getting going up and going. Oh, am I not mirrored here? Hold on, let me in slideshow. Ah, there we go. All right. All right, webpage. You can kind of read it. I definitely stole some free CMS webpage to kind of build the defaults out. But the general idea is that you pick exploits that you want to make, depending on what they are. Some of them I can actually generate the shellcode for in the JavaScript. Other ones are currently hard-coded. I'm working on figuring out how to get like the Java deserialization vulns where you have to generate those long random strings that are like base64 encoded in the JavaScript. I think there's probably a way to do it if I learn better JavaScript. And then you can kind of give it a host and pick. I don't have the output script up here, but here's the thing. So you launch these to a /24 and say scan, and here's some debugging stuff still in there. And it starts to scan that network, but really from the user's perspective, they don't see anything happening. You have to actually open up the console, and you can see that these WebSockets are launching to all these different hosts as it's going, except for I don't have any hosts right now, so they're all just unreachable, so it's not able to fingerprint anything. And we can also launch exploits towards any of these hosts. That we'll see these failed ones. You see it failed that post. If you go into the network tab, it's interesting that Burp doesn't pick any of these up because it uses these WebSockets. So Burp won't actually catch these. So if you're trying to use Burp to proxy any of this stuff, it won't show up. When we get to the C2 part at the end, they originally figured out that like a lot of the network and antivirus stuff isn't looking at WebSocket traffic because it's not really HTTP traffic. As soon as it makes the connection and establishes that it can send stuff to an endpoint, it switches protocols over to this WebSocket stuff that's just kind of like raw data going back and forth. Let me clear here. So if you launch exploit, so the only way to get rid of that scanning from running now is basically to refresh the web page. We'll stop it currently. If I had this embedded as just a script, it basically just keeps on running. No matter what, if you're on that page, you're always going to be getting your network scanned and trying to identify hosts that are live and fingerprint them. So if we try to exploit something, I don't want to exploit everything. Let me exploit one thing. You see this gets picked up. It's only going to show up really in this network tab. This network tab kind of gives you some debugging. I don't know that you can read all that. Whoops. But this attack, so this shows like the payload. This is one of those serialized objects that it tried to send to 10.0.0.0.1 that ideally would generate me a reverse shell that then would call back home to whatever attacking server I have set up on my new Azure command and control servers. Some of the other features are coming. One I really want to add that's going to be kind of the next step, which is in a different development mode, but it will generate, basically you tell it a range or whichever you want to scan. It'll generate minified JavaScript that basically will look like, if I can bring this back up. It will look like, nope, this. So if you've ever read minified JavaScript, you see these in web pages all the time. They usually reference things, they're trying to save space on the resources they load. You're not going to have an easy time trying to find out that I've got exploit code in there that's scanning the network and sending exploits. And it's very common. And if you've ever visited any popular web page and kept that network tab open, they make all kinds of different requests, and all these tracking cookies that are built into every website that we've all heard about, that all shows up there. It's very hard to kind of look through and differentiate between the different things. And then I just started thinking of more ideas you could do with this. One thing is I think that it could level up phishing quite a bit. I don't know why most phishing campaigns usually just send people to a page and try to accept just they try to get credentials. As long as that person has something up, you could basically be scanning their internal network. All you need is them to click then. So you don't actually need them to accept anything. It just opens the page and starts running. And you can halfway reliably scan their network depending on how long they spend there. And then if they have any of those vulnerable hosts inside their network, you can exploit. One thing that it does require though is them to hang on the page. So one idea I had was like if you've ever played like Flappy Bird or any of those embedded JavaScript games, you could throw something like that up, get people to click on it, they sit there and play that game for a while and don't know they're getting scanned during that time. Yeah, that. The next thing I was looking at was mobile device profiling. So, and this is probably being used already. I think most of this is probably being used already. I just am surprised it's not talked about more because it's all been out for quite a while. And all this was back in like 2015 that the browsers really implemented most of these features. Was dealing with deep links. Deep links allow web pages to launch applications out of the web page. So if you've ever visited like Facebook and then it launches like, hey, we want to just launch this on Facebook, or like YouTube will then just open in YouTube. They're basically using deep links, and those look like, for Facebook, it's just FB://. It's kind of like the protocol becomes whatever, they have to register it in their URL scheme. They register it in the App Store, or with Android it's a little bit different because it's in the manifest file. Anyways, what I was able to do was host a web page that then launches a bunch of these deep links and then makes a request back. Well, I have it here just changing the page itself so I can test. This isn't the greatest idea because it does then launch the app, and then as soon as it launches and doesn't time out, it closes it. So you see like Facebook open, YouTube open, all these apps start opening when you're on this web page. But you can kind of reliably also figure out what other applications this mobile user has just from them hitting your website. I did a bunch of work on that, trying to make it like close faster and work and everything, and then I found out that Chrome has an experimental feature called Get Enabled Apps that just lets the web page access all the apps that are available. So that's coming. It's experimental now, but I'm assuming they're going to get there. Their hope is that developers are going to start registering which sites are allowed to query them. The problem is now, if you don't register, then any site can query if you have an application there. So I can then profile whether you have a bank or just different things you can kind of figure out about someone just from them visiting your web page. The next stuff is WebUSB, and this did get talked about a little bit earlier on Web Bluetooth, but WebUSB, it's this awesome feature that lets the browsers interact with anything plugged into USB ports on your computer. Recently, Marcus and Anti-Snatcher, one of the co-authors of Beef, gave a presentation, it was like in January, where they were able to bypass two-factor YubiKeys. Because of the YubiKeys, you have to plug into a USB. They used a phishing page that could access those USBs, take those tokens, and then submit them, and be able to bypass those like hard tokens. And that's just more of an HTML5 feature. Another one that came up earlier was the Cloud Pets. The guy found out that he could write a web page that used Web Bluetooth to access and then talk to the kids' pets that were in range of the computer. These are all just built-in features. Web Bluetooth is one of the experimental ones. You have to enable it, I think, right now. WebUSB is enabled currently. It will pop up and ask you about stuff. I think their demonstration was kind of a page that was just a phishing page that required their YubiKey to be entered, and they were just able to access the YubiKey's values and then submit it to the actual site instead of the fake phishing page. Looking forward, I want to keep on working on more payloads. There's lots of different CSRF website opportunities. If you've ever done any like WordPress hacking, you know you can, as an admin, write pages that have PHP stored in it and give yourself like a backdoor. So if you could start to identify users when they hit your cross-site scripting that are logged into a WordPress site somewhere on their internal network, you can then make those post requests that upload malicious PHP and kind of give yourself backdoors on web pages, so there's a lot there. I don't have any of the USB or Web Bluetooth stuff, I'd like to add that. Outputting just the minified payloads with just the single exploit is kind of the next feature that's almost done. And then something I found recently while I've been looking at all this is using WebSockets as a command and control server. This guy, I don't know his real name, his hacker name's like Arnox Fox, I think. He found out that IE and Edge have access to the the component object model in Windows, and he can actually use IE and Edge as a C2, and it's all over WebSockets. His specific task was he was hacking like blue code proxies and found out that blue code proxies just ignore WebSocket traffic because it's not technically HTTP or HTTPS, and is able to kind of reliably use WebSockets as a C2 on an internal network. And that's all I got there for that stuff today. All right.